Well, hello again. So today we are solving systems by substitution, but now something weird's going to happen. Maybe you might solve the problem and it's totally normal, just like it has been, or something odd is going to happen, something different than what we've seen before. So if we take a look at the very first one, let me just zoom in a little bit more here. The very first one is already weird because look at the first equation. It just says y equals -1. So I just want to remind you, if this were, if you were graphing this, right? If you were graphing it on an x and y coordinate, remember how to graph y equals -1? Of course you do, because you're thinking hoi bucks, right? So if I were to graph y equals -1, it's just a horizontal line at -1. Okay, and then if I were going to go ahead and graph, you don't have to do this, I'm just explaining this to you, because you can obviously have two lines cross where one of those lines just happens to be a horizontal line and the other one is something else. So if I look at the bottom one, if I were to graph that, I'll do that real quick with y-intercepts. Let's switch colors to green for that. That would have a y at -1. And then x is going to be weird. It's going to be at a 1 and some -1 and some change. So, yeah. Okay. So if I, that's not a very good line. Let's see if I can do better. There we go. So these two do have an intersection point. Looks like it's actually at 0, -1. But so I just wanted you to be able to visualize, yes, you can have two lines cross and one of them could be a horizontal line or a vertical line, right? That happens all the time. So how do we solve that algebraically? So we're not going to graph it. We're just going to solve it with our system like we normally do. So think about what our steps have been. Our goal has always been to get one of the variables by itself on one side of the equal sign. Well, you already have that. You have it right here. You already have y by itself. In fact, you already have the answer for y. A problem like this is actually a little bit easier because you have half the answer already. You already know what the y coordinate is. It's going to be something, comma, -1. Right? They're telling you half the answer. So literally all I have to do with a problem like this is plug in -1 for y in my other equation, and then just solve for x. That's really all there is to it. So these are actually a little bit on the easier side. So let's add 7. We already know the answer because I did the little graph for you, but you're not going to graph these. So in real life, you wouldn't know what the answer is yet. But there we go. I just so happen to have gotten 0 this time. So when you see one of your variables already solved, think of it as a gift because you're like, great, I already have half the answer. Let me just plug it into the other equation, solve for what I'm missing, and I'm done. Okay, so now let's take a look. That wasn't that weird, right? Ugh, I'm still getting used to this erasing everything. Oh my gosh, there we go. Okay, let's slide over to the second one. Okay, so this one doesn't look like the first one. So I don't have that cool little thing where something's already isolated. Okay, that's fine. So just like in the last session, we kind of scanned both of our equations and we tried to find one variable that was going to be easy to get by itself. Doesn't matter if it's x or y, doesn't matter which equation it's in, right? I just want to look and I want to see, okay, well, if I'm just happening to notice on the top one, if I just got rid of that 2y, if I just oh, what happened? Oh, sorry, my screen just went all crazy. Am I still in this back to meeting? Let's see. Okay, there we go. Sorry. All right. So anyway, if I minus 2y from both sides, that would get me the x all by itself, and that's what I want to do. So I'm going to go ahead and just rewrite this down here. X plus 2y equals 2. And then we'll minus that 2y to the other side. So now I'm here. X equals 2 minus 2y. So let's switch colors. I'm going to take everything that x is equal to, and I'm going to plug it into the equation that I have not touched yet. So that means I'm going to put it right there. Okay, let's go ahead and do that. 3 times everything that x is, 2 minus 2y plus 6y equals negative 4. Let's distribute that 3. 6 minus 6y plus 6y equals negative 4. Let's combine like terms. I have negative 6y plus 6y, so in this case, they just cancel each other out, right? So, weird, right? We said that something weird was going to happen. Well, something weird just happened. The y's canceled out, and I'm left with 6 equals negative 4. Well, does 6 equal negative 4? Of course not. No, it does not. So, that's not true. 6 does not equal negative 4. When this happens, can you guess what this means? What does that mean? I didn't mess up. So one thing that you do want to check, go back and see, did I make any errors? On this worksheet, you probably did not make an error. There are going to be weird things that happen, and that's one of them. Think on some of the other things that we've done. What does it mean when I get something bogus like this? 6 does not equal negative 4. What does that mean? So hopefully you came up with the answer of no solution. Why would these be no solution? What has to be true for 2 lines to have no solution? If you're remembering from when we did graphing and you're thinking, oh, they must be parallel lines. Yes, you are absolutely correct. These 2 lines are going to be parallel, which means that if you rewrote them into slope-intercept form, they would have the same exact slope, but different y-intercepts. Okay, so that's what this means. If everything cancels out, your y's just kind of went away, but your solution makes no sense. Okay, means no solution. Let's try the next one. Okay, so here's another one where nothing is necessarily, I don't have any variables isolated yet, but I could see pretty easily with this one right here, if I just, actually I'm gonna switch away from yellow. It's a little hard to see. Let's do blue. So let's just go ahead and I'm gonna minus 2x from both sides to get the y all by itself. So now I have y equals 0 minus 2x is just negative 2x, right? You don't even need to write the 0. You can if you want, it doesn't really matter. And now I have y all by itself. So now I'm going to take everything that y is equal to, and I'm going to plug it into the other equation that I have not touched yet. So it's going to pop in right there. So let's see what this looks like. Negative 6x minus 3 times everything that y is, which is negative 2x, equals 0. All right, let's go ahead and solve this one. We'll distribute that negative 3. So it'll be a plus 6x equals 0. Huh! Weird! Look at the left-hand side. Negative 6x plus 6x. Well, isn't that just 0? And there's nothing else on the left-hand side. So you just get 0 equals 0. Weird! Now, this is different from number 2, because in number 2, I got something that was totally untrue. 6 does not equal negative 4. However, in this one, number 3, 0 does equal 0, but all my variables are gone, right? Everything canceled out, but I am left with a true statement. So can you think what this means? Think back to graphing. There was 3 scenarios. Most of the time, the 2 lines crossed just like normal and everything's fine. Sometimes you had parallel lines, and then what was the other case? I wonder if you're thinking that these are the exact same line. If you rewrote these into slope-intercept form, they would literally be the exact same line. Same slope, same y-intercept, everything's the same. So what does that look like? If you're graphing it, it literally looks like you have one line and then you have your second line is literally right on top of it. They're the same line. So what's the answer? Well, there isn't just one answer, right? There's how many? If you're thinking an infinite number of solutions, you are correct. That's what this means. Remember, it's different from all real numbers. That's not what you're saying here, because that's not true. There's plenty of numbers that aren't going to work in this system, but there's no shortage of answers, right? So that's why we're going to say infinite solutions. Okay, so that's what something like this means. And it doesn't necessarily always have to be 0 equals 0. You could end up with something like 4 equals 4 or -9 equals -9. Everything else is gone, but you are left with some true statement at the end. Very often it's 0 equals 0, but it doesn't have to be. Could be anything, as long as it's true. If it is not true, if it is like we saw in number 2, that's when you have no solution. Okay, we'll try one last one together. Let's see what that one brings. Okay, number 4, okie dokie. So I'm seeing the top equation. I'm gonna rewrite it over here. 5x plus y equals 17. So if I just minus 5x from both sides, I'll have that y by itself. So y equals 17 minus 5x. Y is all by itself. Everything that y is equal to, I'm gonna take it and I'm gonna pop it in. Boop, right there. Okay, take it to the equation you haven't touched yet, plug it in. So let's switch colors. Negative 3x minus 3. Now everything that y is, 17 minus 5x equals 9. All right, let's distribute that negative 3 and see what happens. So 3 times 17 is a negative. 30 and 21 is a 51. Plus 15x equals 9. Okay, a negative 3x and a 15x is 12x. I'm going to add 51 to both sides. 9 and 51 is 60. Divide both sides by 12. X is just going to be 5 in this case. So once I have one variable, remember I'm going to go right back to that box and plug in what I have. So y is going to equal 17 minus 5 times 5. 17 minus 25. 17 minus 25 gets me a negative 8. So my answer here is just going to be a 5, negative 8. But Mrs. Sabia, there's nothing weird about that. Yeah, I know. Ha! They can't all be weird, right? Some of them are just going to be normal. So sometimes you just get a normal, the 2 regular old lines crossing at 5, negative 8. Sometimes they're going to be parallel lines and they'll have no solution. Sometimes they're going to be lines right on top of each other and it's infinite solutions. So it's up to you to be able to figure out which one it is. So I've mixed regular ones in here. There are some that are no solution, there are some that are infinite, and there's some that's regular. Okay, so give them a shot. Hopefully you don't have too much trouble on this one. Okay, so reach out if you do though. We're here all day.